this will explode. And a good example was in one of the buildings there we have inspected that even a good mahogany, yakal, or yiho, okay, even that kind of wood, I've seen woods or panel doors has exploded in half. Pwede niya yan putulin and even everything when the shaking is so much. So, it will now be categorized on the hazards. Okay, so kung makita niyo itong mga ang daming cracks and even the explosions where the steel bars are already exposed. Okay, ang plaster nawala na, the paints and then the steel bars are already exposed and even some portion butas na siya, you can see through. That is now the out of plane deformation. So it can be declared even if this is a hazard to be part of level 2 because level 2 is repair and retrofitting or removal. Or this is also partial demolition. And then you will also notice on the structures which has parapet. So when you say parapet, parang galing sa extension sa mga top sa building. So if this is now your building, like for example, if it's a 3-story building, yan ay extension din na sa taas. Yan nag-roof deck ka dire. Okay? If that is your roof deck and there are these parapets. Parapets are also hazards and so many. Especially on big establishments, they have parapets at the top. If it is not designed properly, okay, even if it's not structural, nagkisi-kisi na imong building na it's shaking and shaking, okay, the same principle, mabali lang na sa diretso, mahulog siya. Okay, so those are falling hazards, even if it is not structural. Architectural or ordinary finishes, it can be leveled or categorized like that. Okay, so what do we do now? So when we check, okay, ano yung unahin natin? We look for the columns. If you see these things, they always come in pairs. Okay, mag-asawa, left and right, top and bottom, and then we look at the beams, and then we look at the walls, okay, and the ceilings. Okay, how do we apply this principle also? Now look at these corners of the ceiling. If the structure will also shake differently, like for example, stretching, compressing, rotating, translating, okay, what happens is, it's like the wall. Okay, it's like the wall. Magbuntis na siya pababa. Okay, or it will go up and down. But since gravity is pulling it downward, so the likelihood of going down is really possible. So, ang una na mga tanggal are the rivets, the W clamps, if it is a not wood, yung tinatawag na hardiflex. You remember yung pagkabit ng natin ng hardiflex are small rivets only. Okay? So hazard talaga yan siya. Although it's not structural, but the possibility of falling is very, very high. Okay? It will explode. So it will start also like this. So imagine this is now your ceiling. It will create these parts. And sometimes, since the rivets has very, very low resistance, there is no warning. Mabuti pa itong wall, may warning. Ang rivets, wala. Pag nahulog yung isa niyan, it's like a domino effect. If it will start on that corner, tuloy-tuloy na yun. Okay, so as engineers and maybe contractors and developers, maybe we can talk later to really improve yung tinatawag nating W clamp. Sino bang nagko-construct dito using yung mga hardiflex na ceiling? Meron ba? Can you raise your hand? Wag naman kayo mahiya. Yes sir. Okay. So, I encourage you na pag gumamit kayo ng W clamp, don't just fold the W clamp and then connect the runner. You add rivets on the W clamp because of this stage. Because the W clamp is just a soft metal, then you just bend it, then sasakay na yung runner mo. Then you put those rivets. So it's like this. So, pag ito yung ano mo, tawag nito yung hard deflex mo, it is now riveted to a runner. I-rivet yan ganon. Then this runner is carried by a W clamp. Para siyang W. Okay? Nakapasok yan doon. And it is only resting on another element like that. So nakapilo lang yan siya ganyan. Now when it goes up and down, this will slowly open. So bigla yung bagsak. So many of those structures we've inspected in Capitol in Tigos, the structure is okay, but the ceilings all fell down because of this. So we recommend na when you repair, you do double riveting on your W clamps just to improve the capacity of your ceiling. So hazards yun siya and falling debris. So okay ba yun? Okay, so let us break for a while and entertain questions. Okay, so I think as you ask your questions, there will be so many things that will come out as we did last Monday. Na the lecture is up to this part, but as the open forum goes out, ang dami pala mga tanong na dapat ilabas. Okay, so who will shoot the first question? Okay, sige. Can we give siguro a microphone para marinig din ng iba? I believe na ano.
Thank you, sir. I'm the chapter president of PIC, North Cotabato. Bago ako mag-question, sir, thank you for coming. I hope makabalo naman tayo na idea. Mo-appeal na mo sa rapid evaluation. Actually, PIC was requested by PRC, Dolly, even the city mayor, LGUs to do rapid assessment. Ang problema, kami-kami lang, kilalang takabuhok. Upat, so I'm happy na nakaroon. So I hope daghan na mag-participate. No? Actually, sir, we are doing a rapid assessment. How about yung mga cracks lang, sir, sa middle part, level 2?
Okay. Okay. So, how about cracks on the middle part? So, this is now where level 2 comes in, where you do a detailed assessment. So, what the president of PICE Cotabato chapter is saying is, if this is the height, what if there is a crack here? Okay, that tells us, that gives us an X-ray vision. Okay? So, the earthquake, as I always say, the earthquake or earthquakes are the greatest revealer of the unseen. So, siya yung nagbibisto. Yung mga tinatago. So, may laman, ano? Okay. Okay. So, I'll say it again. Earthquakes are the greatest revealer of the unseen. Okay? So, huwag kayong magagalit because earthquake is a respecter of no person. No? So, ngayon, pag ganito na yung mga nangyari dito, it tells us something of what is inside. Okay? Pag meron mga horizontal cracks in the middle, which is really very unexpected. Because a good column, even when it is damaged, should always manifest the damage at the bottom and at the top. Sa leeg or sa kilikili and at the foot. When there is this crack here, it tells us that the column is slender. Parang gusto niyang maging malambot. Gusto niyang gumewang-gewang. And what gives the column that flexibility? It is either the column is small or the reinforcement is few. Kulang yung bakal, kulang din yung stirrups. Because the nature of the behavior of the column should always be, if there is an earthquake, it should be like that, pag may lindol. Now, pag ganon siya, ibig sabihin yan, somehow, the column is overloaded vertically. So gusto niyang lumuhod, pero ayaw pa niya, kaya pa niya. So, it will be manifested by these cracks. Okay, if this is now the case, this is now where you need to do detailed assessment. So when we say detailed assessment, you have to look at the plans, okay? Look at the size of the columns, look at the number of bars inside, what is the size of the bar, so if you will have some cross-section there, if that's the column. Example, apat lang yung bakal. Okay, what we call the main bars. Okay, and it is looped by stirrups or hoops. Okay, if this is so little, it gives flexibility. Okay, if this is spaced farther, it gives flexibility. So the issue now is, if we will see this, we have to look at how big is the crack. Okay, so when we say how big is the crack, if it is more than a millimeter, okay, a millimeter, saan na siya? Gamay, kanang mo drawing ka gana, roughly, this is more than a millimeter, no? So, smaller than a line of a pen. Okay, that is a hairline crack. So, it gives us an idea that it can only be plaster lang. Plastering. So, the building can just sway, okay, because it has some flexibility, but it poses no danger kapag maliit lang yun. Tinatawag natin hairline crack. Okay? But just to be sure, if you have no capacity of measuring it, have it consulted or have it checked by engineers and looking at the sizes here and do some analysis if this is really enough to withstand yung shaking. So, when the structure is slender, yun ang usual na nangyayari. So you will notice in Eva Hotel, the damages are not here. So the sizes are enough, but the weakness are at the joints. So dito naman yung may problem. Okay ba yun, sir? Okay. So other questions? Yes, sir. Introduce sir.
Architect Erwin Budahero from the Provincial Engineer's Office. In addition to the question of our President, a crack manifested at the middle. In the case of the province, we have invited personnel from PICE and nagdala sila ng hammer-bound, ang tawag doon?
Hammer-bound equipment.
And they have inspected the building, and the result says that from here, it registered 30 megapascal strength of concrete, but on the upper side is only 15 megapascal.
Okay, that's a good input. Meaning, the strength of the lower portion of the concrete is strong, but the upper portion is weak. So wala siya continuity, and that is a poor construction execution. Thank you, sir, for bringing that up. Because when we design a column or the beams, ang buhos ana, if there is a specification of 3,000 PSI or 21 megapascal, it should be from start to finish. Huwag mong babaguhin. So, earthquake again is the greatest revealer of the unseen. Okay. Yes, ma'am.
50% savings.
Ayan, yan. May microphone doon.
Ito next na ano niya, sir.
Pakilala ka muna para
Engineer Amira Bido po.
from
Private po.
private. Okay.
Possible ba, sir, na yung strength ng isang building, sir, if madaanan siya ng yung sa kagaya ng earthquake, sir, possible ba na mag-decrease yung strength, sir?
Okay. So, possible ba na mag-decrease ang strength? When the building is designed, no, we engineers are bound for how many years? 15 years. Article 1723 of the Civil Code.
14 years ba yan? Puro story, bro. Next year, kaya naman 15.
Meron tayong lawyer konti dito. So 1723, tandaan yan. And it's good to see this. Whether you're an architect, okay, an engineer, or even a designer, much more, and a project manager, as long as you are part of that, you are liable for 15 years. No? So, liable talaga tayo yan. That's why we really have to take our responsibilities very, very seriously. Okay, so the question is, ano ba siya? Yung mag-reduce ba? When we design the building, it is our responsibility to design a building. So based on our design philosophy, sa ngayon, no, we are to design a building that should withstand a magnitude 7 earthquake. Lahat tayo. Okay, so walay hangyuay. So what happened was, it's only a magnitude 6.5 and so many structural damage. So when we say magnitude 7, we're simply saying that when there is a magnitude 7 earthquake, there are damages but not collapse. Dapat ganun. Pag may sabi tayong damages, even these things are still accepted for as long as it is repairable and standing. Even if there are hazards na mag-explode yung wall, magnitude 7, yun yung minimum requirements natin. So by the way, since you've asked that question already, every earthquake will always decrease when there is a damage, decrease the capacity of the building. So it is our responsibility now is what to do next. Are we going to say, okay lang yan, maliit lang yan na crack? We have to be responsible to do something about it. Whether urgent, or later on, or scheduled, or kung sa ano pa natin, sa physical condition natin, yung elective operation, at isa ako magpatanaw kay doktor, kaya I feel okay, or something is happening na there inside. Okay? So, presently, our design philosophy is we have to design a ductile structure. Now, there are actually these 3 design philosophies. Agihan na naman eh. You will notice that in the olden days, buildings such as the Pyramid of Egypt, the Victory structure in France, no, and the Eiffel Tower, they are designed on the fully, or what you call this, fully rigid structure. Meaning, when the structure, erase ko na lang ha, when the structure is subjected to a shaking, when the structure is subjected to a shaking, for example, this one, and the ground will move. When we say it is a rigid structure, when the ground will move in that direction, the structure will move in that direction at the same time. Ganon siya. So buong structure siya. So if it is this eraser is a structure, when the ground moves, the structure will just move together with the earthquake. Okay, yun yung rigid structure, or others will call it elastic structure. Meaning you don't allow the structure as much as possible to experience large deformation. Kahit pa anong music yan, walang damage. But that is going to be a very, very expensive structure. So in the late 19th and 20th century, they proposed what we call a ductile structure. When we talk about ductile structure, it means the structure should be a little bit flexible, but not to the point of so much movement and too much flexibility that it will already cause discomfort on the occupants, and at the same time discomfort or damage on the equipments inside, especially for medical structures or hospital buildings. Okay, so what is this? So ito yung una, design philosophy number 1 is rigid structures. So, gumagaling daw ang mga engineers. So, they now went to the ductile structures. So, when we say ductile structures, so, hindi si Donald Duck, ha? Ductile structures. So, when we say ductile structures, it means that when the building moves here, it is allowed to sway to a certain degree. So, when the building when the ground moves here, the building will sway a little here. But the roof displacement or the drift, meaning the story-to-story difference, is controlled. So we call this delta na lang. No? This should be very, very small to an acceptable limit, which is limited by the code, which is the National Structural Code of the Philippines, which is also copied to the Uniform Building Code of the United States. Okay, so ito yung kinokontrol. When this is controlled, then the building is just allowed, when the earthquake is applied to the building, it's just to move kukunti lang sa taas and succeeding on this building. But this will cause some damage. Now, sometimes this is abused. Pinapalakihan masyado yung movement, and that's why nagmamakarena yung building until it experiences damage on the structure. So this is the ductile structure. Now, countries like us and even other countries na developing pa, we are in this design philosophy. Okay? Nandito tayo. Other countries like Japan and the US and Europe now migrated to another design philosophy, which is the base isolated structure. So when we talk about base isolated structure, if this is now our building, these are our columns, we isolated the base of the structure from the ground. So anong ginagawa nun? If this is the footing of the building, okay, meron tayong kinakabit na mga springs or base isolators that will now be resting on a very big foundation. So you will notice, I think someone posted there when I posted that video, you just look at in the YouTube, ano itong base isolators to give you idea. So when the earthquake happens, the base, this one, the big base is attached to the ground. Now there is here what we call base isolators, okay, or springs or plates, whatever is designed or available in the market. The shaking will be confined on the ground and the structure will just shake so little. So what happens on the occupants sa taas, they will not experience or sense a very strong motion on the top. Now let us give an example. If you will use a rigid structure and you are in a hospital, nakadextrose doon, nandoon yung mga aparatos na nakatayo doon, even if the structure does not fall, you being inside, you are not attached to the floor by law of inertia, yung napag-usapan natin, you will move everywhere inside the room and your equipments will also move around and there will be destruction inside the building, but the building remains intact because it is rigid. Tama, no? Okay. Now, if you are doing also computer activities in the bank, may mga servers mo doon, and you're in a rigid structure, in a vault, so matutumba rin yung mga doon, and even the persons inside may hilo. The ductile structure reduces that. But the problem also is after an earthquake event, there is always a repair. And during the event, people has to run outside. Tatakbo ka. Kasi hindi mo alam, ano bang capacity ng building na yan. Okay? For a base isolated structure, okay? Base isolated structure, when the building happens, like for example, if this is a hospital or a government office, they just sit there and stand and wait until the earthquake is completed. Then all the other structures designed in this design philosophy and other philosophy will run there for medication and medical attention. So yun yung advocacy ko na for people, no, who has connections everywhere, if we can tell the DepEd or the CHED, Commission on Higher Education, the PRC, to modify slowly the curriculum for engineers to migrate slowly in this. It may be expensive at the beginning, but when so many people will be into this, it will be reasonable already. And cost-wise, if we try to look at this, because this will experience less stresses, the member sizes will be smaller compared to this, much less this one. So ito yung direction niyo. So this is just an aside in relation to that. But since we are forever married to earthquakes, meaning the Philippines is always and forever, till death do us part, married to earthquakes. We are responsible to design our buildings that will be resilient against earthquake damage. Okay ba? So mas lalo bumigat yung responsibility natin, no? And that is why we are so thankful. Personally, I am really thankful that there are gatherings like this, because whatever idea we can have, I'm not saying that I have a monopoly of knowledge. There are other people who has better understanding about these things, but this is only a small contribution of mine to help people, especially in places like Pinapawan that was hit by earthquake. And for this, when this information is disseminated and propagated, then we can help Mindanao rise again. Okay ba? So, other questions? Meron pa bang magtanong? Yes, ma'am.
Tanong ko lang po.
Para marinig.
Kagaya po ng mga tulay, mayroon siyang capacity. For example, capacity ng tulay 10 tons. Pero yung mga buildings, wala pong nakalagay na printed na ganun. Dapat po ba mayroon din ganun ang mga capacity yung mga buildings?
Okay, so I'll just repeat the question. Ang mga tulay daw, meron 10 tons, 28 tons, 38 tons. So ang building din ba dapat meron? Actually, you don't have to say it, no? Or to ask, building is only up to this one. But to self-regulate ourselves, no? Kung ikaw yung owner ng building or ikaw yung designer ng building, the code tells us that whatever type of occupancy the building is designed, you have to design it to carry that load. For example, this area, this assembly area here, if this is placed on the second floor, congregating area, we have to use 100 pounds per square foot loading. Minimum yun. Pag ano lang, pag yung mga residential and offices lang, so you have to design it at 50 or 40 pounds per square foot. And classroom, so pwede natin ilalagay yon. Pag bodega naman, that is 200 to 300 pounds per square feet. Now the question is, and I have seen so many and retrofitted buildings which changed its use. Dinesign siya na normal occupancy lang, tapos later on ginawang bodega. Tapos sasabihin ng may-ari, baratuha lang na pag-design engineer. Then the engineer will say, what is your usage of that building? At tao raman na, tuharang katao maglakaw-lakaw din na. Okay na yan. O sige ha, but you are the engineer and you know this person is not really telling you the truth. And you know better. So even if he says na dalawang tao lang yan, then at least you design it na merong assembly, use 100 pounds per square foot. Unless you are really very, very sure na dalawang tao lang yung dadaan dyan, then you say it's at least